National Electrical Safety Code Section 110.34 addresses clearances for substations and other electrical installations operating above 1 kV. It mandates a minimum clearance of 10 feet from live parts to the ground and surrounding objects. Section 110.31 pertains to clearances for overhead lines and equipment operating at less than 1 kV, specifying a minimum clearance of 3 feet from live parts to the ground and surrounding objects. The local utility, JCPL, requires 10 feet of working clearance in front of transformer doors to facilitate maintenance and operational activities. Because the medium voltage switch operates at 14.4 kV, it falls under the purview of Section 110.34. Consequently, a minimum clearance of 10 feet must be maintained from all live parts of the switch to the ground and surrounding objects, including the fence. To guarantee adherence to both National Electrical Safety Code and local utility stipulations, it is advisable to establish a 10-foot clearance around all sides of the transformers and the medium voltage switch. The fence should be engineered to endure the potential impact of airborne objects or personnel and afford sufficient access for maintenance tasks. It should be fabricated from robust materials and feature lockable gates to regulate access. Maintaining proper clearances around electrical equipment like transformers and medium voltage switches is crucial for safety and compliance with regulations. These clearances ensure that individuals can safely work around the equipment and prevent accidental contact with energized components. Firstly, the National Electrical Safety Code, or NESC, provides guidelines for safe electrical installations and operations. Secondly, Section 110.34 of the NESC specifically addresses clearances for electrical equipment operating at voltages above 1 kV, requiring a minimum of 10 feet clearance from live parts to ground and surrounding objects. Thirdly, Section 110.31 applies to equipment operating at less than 1 kV, with a minimum clearance requirement of 3 feet. Fourthly, local utility companies like JCPL may have their own specific clearance requirements, which must also be followed. Fifthly, in the case of transformers, JCPL requires 10 feet of working clearance in front of the transformer doors for maintenance and operational purposes. Sixthly, for medium voltage switches operating at 14.4 kV, Section 110.34 of the NESC applies, necessitating a minimum of 10 feet clearance from all live parts to ground and surrounding objects. Seventhly, when designing a fence around electrical equipment, it is essential to consider all applicable clearance requirements from the NESC and the local utility. Eighthly, a recommended approach is to provide a 10-foot clearance around all sides of the transformers and medium voltage switch to ensure compliance with all regulations. Ninthly, the fence itself should be designed to withstand potential impacts and provide adequate access for maintenance. Tenthly, it should be constructed of durable materials and have lockable gates to control access to the equipment. Understanding and adhering to these clearance requirements is essential for creating a safe and compliant electrical installation. Ignoring these guidelines can lead to dangerous situations and potential violations of regulations. Always consult the latest editions of the NESC and local utility requirements to ensure that your installation meets all necessary safety standards. Remember that these clearances are in place to protect individuals from electrical hazards and to ensure the safe and reliable operation of electrical equipment. Careful planning and attention to detail are crucial when designing and installing electrical systems. Ensuring adequate clearances is a fundamental aspect of electrical safety. Proper fencing is also a critical component of safety around electrical equipment. Fences serve as a physical barrier to prevent unauthorized access to potentially dangerous areas. They should be designed and constructed to meet specific requirements based on the equipment they enclose and the surrounding environment. The height of the fence should be sufficient to deter climbing or jumping over it. The materials used for the fence should be durable and non-conductive. Gates should be self-closing and equipped with locks to prevent unauthorized entry. Warning signs should be prominently displayed on the fence to alert individuals to the presence of electrical hazards. Regular inspections of the fence should be conducted to identify and address any damage or deterioration. Maintaining a secure and well-maintained fence is essential for preventing accidents and ensuring the safety of the public. The specific requirements for fence design and construction may vary depending on local codes and regulations, so it is important to consult with qualified professionals to ensure compliance. Clearances around electrical equipment are not arbitrary measurements. They are carefully calculated distances based on the voltage of the equipment and the potential for electrical arcing. Electrical arcs can occur when there is a sufficient voltage difference between 2 points, causing electricity to jump through the air. These arcs can be extremely dangerous, causing severe burns and even death. The minimum clearance distances specified in the NESC and other codes are designed to prevent such arcing from occurring. These distances are based on extensive research and testing to determine the minimum safe distance for different voltage levels. It is important to understand that these clearances are not just guidelines, they are mandatory requirements that must be followed to ensure safety. Failure to maintain adequate clearances can result in serious consequences. In addition to preventing arcing, clearances also provide working space for qualified personnel to safely maintain and repair electrical equipment. Adequate working space allows electricians and other technicians to perform their tasks without being exposed to electrical hazards. This working space must be clear of obstructions and provide sufficient room for movement. The NESC and other codes specify minimum working space requirements based on the voltage of the equipment and the type of work being performed. It is important to ensure that these working space requirements are met to protect the safety of workers. Working space clearances are often overlooked, but they are just as important as other clearance requirements. Providing adequate working space is a fundamental aspect of electrical safety. The importance of consulting with qualified professionals cannot be overstated. Electrical systems are complex and potentially dangerous, and it is essential to have the expertise of qualified professionals to ensure that they are designed, installed, and maintained safely. Qualified professionals have the knowledge, skills, and experience to identify and address potential hazards and to ensure compliance with all applicable codes and regulations. They can also provide valuable advice and guidance on how to optimize the performance and efficiency of electrical systems. When selecting qualified professionals, it is important to verify their credentials and experience. Look for professionals who are licensed and insured and who have a proven track record of success. It is also important to check their references and to talk to previous clients to get a sense of their quality of work. Investing in the services of qualified professionals is a wise decision that can save you time, money, and potentially your life. Do not hesitate to seek the help of qualified professionals when dealing with electrical systems. Remember that electrical safety is not something to take lightly. It is a serious matter that requires careful attention to detail and a commitment to following all applicable codes and regulations. By understanding the importance of clearances, fencing, and qualified professionals, you can help to create a safer environment for yourself and others. The National Electrical Safety Code, often abbreviated as NESC, is a comprehensive set of standards that governs the safe installation, operation, and maintenance of electrical power and communication systems. It is published by the Institute of Electrical and Electronics Engineers, IEE, and is widely adopted by utilities, electrical contractors, and other stakeholders in the electrical industry. The NESC covers a wide range of topics, including clearances, grounding, wiring methods, and equipment requirements. It is updated regularly to reflect the latest technological advancements and best practices. The NESC is a valuable resource for anyone involved in the electrical industry, providing guidance on how to ensure the safety and reliability of electrical systems. Compliance with the NESC is often required by law, and it is essential to understand its provisions to avoid potential hazards and violations. The NESC is a complex document, and it is important to seek the help of qualified professionals to interpret and apply its requirements. The National Electrical Code, often abbreviated as NEC, is another important set of standards that governs the safe installation of electrical wiring and equipment in buildings. It is published by the National Fire Protection Association, or NFPA, and is widely adopted by state and local governments in the United States. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment requirements. It is updated every 3 years to reflect the latest technological advancements and best practices. The NEC is a valuable resource for electricians, contractors, and building inspectors, providing guidance on how to ensure the safety of electrical installations in buildings. Compliance with the NEC is often required by law, and it is essential to understand its provisions to avoid potential hazards and violations. The NEC is a complex document, and it is important to seek the help of qualified professionals to interpret and apply its requirements. While the NESC and NEC both address electrical safety, they have different scopes. The NESC primarily covers electrical power and communication systems outside of buildings, while the NEC primarily covers electrical wiring and equipment inside of buildings. There is some overlap between the two codes, and it is important to understand which code applies to a particular situation. The NEC often references the NESC for certain requirements, and vice versa. It is also important to be aware of any local amendments to the NESC or NEC, as these amendments may add or modify the requirements of the codes. Local amendments are often adopted to address specific conditions or concerns in a particular area. Staying up to date on the latest versions of the NESC, NEC, and any local amendments is essential for ensuring compliance and safety. Regular training and continuing education are important for staying abreast of changes in the electrical industry and for maintaining the skills and knowledge necessary to perform electrical work safely. Electrical safety is a continuous process, and it requires a commitment to lifelong learning. In addition to codes and standards, there are also many best practices that can be followed to enhance electrical safety. These best practices may not be explicitly required by codes or standards, but they can help to reduce the risk of accidents and injuries. Some examples of electrical safety best practices include using insulated tools, wearing personal protective equipment, de-energizing equipment before working on it, and performing regular inspections of electrical systems. Implementing these best practices can help to create a safer work environment and to protect the public from electrical hazards. Electrical safety is everyone's responsibility, and it is important for all individuals to be aware of the potential hazards and to take steps to protect themselves and others. By working together, we can create a safer electrical industry and a safer world. Electrical safety is not just about following rules and regulations. It is about developing a culture of safety that permeates all aspects of the electrical industry. This culture of safety should be based on a commitment to continuous improvement, a willingness to learn from mistakes, and a respect for the potential hazards of electricity. By fostering a culture of safety, we can create an environment where everyone feels empowered to speak up and to take action to prevent accidents and injuries. Electrical safety is a shared responsibility, and it requires the active participation of all stakeholders. The importance of regular inspections cannot be overemphasized. Regular inspections are essential for identifying potential hazards and for ensuring that electrical systems are operating safely and efficiently. Inspections should be performed by qualified professionals who have the knowledge and experience to identify potential problems. The frequency of inspection should be based on the type of equipment, the operating environment, and any applicable codes or standards. Inspections should include a thorough examination of all components of the electrical system, including wiring, connections, grounding, and protective devices. Any identified problems should be addressed promptly and effectively. Regular inspections can help to prevent accidents, reduce downtime, and extend the life of electrical equipment. Investing in regular inspections is a wise decision that can save you time, money, and potentially your life. Do not neglect the importance of regular inspections when it comes to electrical safety. Grounding is a critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which can help to trip circuit breakers and prevent electrical shock. Grounding systems should be designed and installed in accordance with applicable codes and standards. Grounding electrodes should be properly sized and installed, and all grounding connections should be tight and corrosion resistant. Regular inspections of grounding systems should be performed to ensure that they are functioning properly. A properly grounded electrical system is essential for protecting people and equipment from electrical hazards. Do not underestimate the importance of grounding when it comes to electrical safety. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overload or short circuit. Overcurrent protection devices should be properly sized and installed in accordance with applicable codes and standards. Overcurrent protection devices should be regularly tested to ensure that they are functioning properly. A properly designed and maintained overcurrent protection system is essential for preventing electrical fires and protecting equipment from damage. Do not neglect the importance of overcurrent protection when it comes to electrical safety. Personal protective equipment, often abbreviated as PPE, is essential for protecting workers from electrical hazards. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. The type of PPE required will depend on the specific task being performed and the potential hazards involved. PPE should be properly fitted and maintained, and workers should be trained on how to use it properly. Wearing PPE is a simple but effective way to reduce the risk of electrical accidents and injuries. Do not neglect the importance of PPE when working with electricity. Lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. Lockout-tagout procedures involve isolating the equipment from all sources of energy and placing locks and tags on the energy-isolating devices. The locks and tags should only be removed by the person who placed them. Lockout-tagout procedures should be followed whenever equipment is being worked on to prevent accidental energization. Following lockout-tagout procedures is a simple but effective way to prevent electrical accidents and injuries. Do not neglect the importance of lockout-tagout procedures when working on electrical equipment. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in electrical equipment. Arc flash events can generate intense heat and pressure, causing severe burns and other injuries. Arc flash studies are used to determine the potential arc flash hazards associated with electrical equipment. Arc flash studies should be performed by qualified professionals and should be updated regularly. The results of arc flash studies should be used to select appropriate PPE and to develop safe work practices. Understanding arc flash hazards is essential for protecting workers from electrical injuries. Do not neglect the importance of arc flash safety when working with electrical equipment. Electrical safety is a complex and multifaceted topic, and it is important to stay informed about the latest codes, standards, and best practices. By following these guidelines, we can help to create a safer environment for ourselves and others.